Hello and welcome to this tutorial where we're going to show you how to perform participant calibration and assessment. If you've got to this screen, then you will have already calibrated the system, and that was on a previous tutorial, and we're now going to do the actual assessment. So let's click on Start the Vision Screening. Again, because we've done all the calibration steps, we don't have to do that all over again. That's only to be done once. And now we have to do the consent screen. The consent form is mandatory. You cannot perform an assessment unless you've consented the participant first of all. And the two roles that are in play here are the assessor, who is the member of the care team who is performing the assessment on the participant, and the participant who will be a resident, usually with some form of cognitive impairment, and you will need to guide them through the assessment. And it's very important you do that accurately and successfully to get a good result. You need to complete the form here. The assessor needs to put their details in. I'm going to put my name in here. My name's David Knight and I'm the author of this website. And then you need to ask the participant, you need to read this information out to the participant. Bear in mind, of course, it's written in deliberately simple language so that you fully understand what you're doing. And of course, they have to consent to this in order to proceed. If they don't consent to this, then they should not have the assessment. So you're going to click that you consent to the vision screening assessment. You put your details in. My name is Mr. Participant. So we're going to be anonymizing this. And then you're going to ask the participant to sign here. The participant can sign ideally with a touchscreen device, of course. If they haven't got access to one, you can use a traditional mouse or laptop screen. And if you're doing that, of course, then you can sign this area. This box is deliberately very large, and it's because if you have an arthritic condition, perhaps, or some condition which limits your dexterity, you're going to need a large area to write your signature in. And if you make a mistake, of course, you can simply erase it and try again. Once you've completed your signature, which of course is dated, so we know what date the consent was performed, you can then click on the submit, and then either you can print it off or you can save it. In this case, of course, I'm just going to cancel it, but indeed normally you'd be saving it or printing the document to have proof that you've provided consent. Then there's a list of instructions gets up. Again, these are fairly straightforward instructions. The main things to understand is it's really important not to move the participant's head during the assessment or test, because if you do that, then it will throw off the calibration quite quickly, and then you're going to find that very quickly the assessment will fail and nothing will be seen. So this is currently a very good assessment tool for somebody who doesn't move their head a great deal. If they do move their head a great deal currently, this is not a very good way of testing their eyesight. Future versions of the prototype, of course, will deal with that problem and will improve this issue. But for the time being, with the third prototype, that is a limitation. The two sections of this forthcoming assessment are a section where there's lots of dots and a second section where there's lots of bars. The dot section really looks at how it's calibrating the participant. So again, at the moment, the system knows nothing about the patient or the participant. It hasn't seen it yet. It doesn't know anything about them, and it has to learn about them. And that's the next section where it's very processor intensive in trying to understand what the eyes are looking at. Once it's done that, it will then try to do a vision assessment by showing the participant successively more difficult objects on the screen, and if the participant can see them, then it will register that, and then of course it will slowly work out how the participant's vision is. During the assessment, you will want to write a few notes down if you see anything interesting, if the participant mentions anything about seeing things or not being able to see things, and that's really important. And also if they're moving their head around, again, you should document that as well. So we're going to start the assessment now. By the way, if you have any feedback, I'm very, very happy to receive it. I'm very interested in making this better and better. So the only way I'm going to do that is by getting feedback from you lovely people. So if you can please send it in, that would be amazing. So start the assessment. And the first thing it's doing is loading all that complicated background data in. And as it does so, you'll see a picture of yourself appearing on the screen any second now. And then the next step will be the actual starting the assessment. There I am. And again, nothing's happening at the moment because it's still trying to work out, load all the background tasks, and there it's now ready to start. And you'll see there's a message on the screen saying that I'm too close to the screen, which is not unusual. So at this stage, again, as you can see, it's estimating my distance at 43 centimeters, and it's also measuring the best vision I can achieve. And it's simply the image would be too easy at this distance, so I need to move further back. So I'm going to move the participant further back, and once it gets to the right position, the assessment will begin. And as you can see there's a big black dot on the screen, and as it moves around the screen, I'm looking at it. As I'm looking at it, it's getting progressively smaller, a little bit more challenging, and also just simply to improve the accuracy of the calibration. If I'm not looking at the dot, it will turn red, as you saw it flickered red momentarily there, because I wasn't quite looking at the dot. And of course, the idea is that as it moves around the screen, the calibration process becomes more and more refined. It gets better and better at working out what I'm looking at. And therefore it gets a bit more challenging until it reaches the point where it realizes that I simply can't track it anymore if the dot gets too small, for example. Now we're into a different phase. Before we were looking at working out where the edges of the screen were, and now we're just trying to calibrate and get the accuracy as good as possible. As you can see, when the dot moves around, then it starts off red, and it starts off red because I'm not looking at it. When I look at it, it changes to black and it starts to shrink again. Once it reaches a predefined level of accuracy, then it will switch and move somewhere else. And it will do this a few times until it really decides that I'm well calibrated, and it has a good understanding of my eye position and what I'm looking at. Because I'm talking, of course, I'm also moving my head slightly. As I'm doing so, of course, I'm throwing it off a little bit, so this will not be a perfect calibration. But it'll be good enough, I think. As you can see, I'm looking at the middle left dot now, middle right dot, and bottom middle dot here. As you can see, it's following me around. I look up and it follows me up as well. Now it's going to start the assessment, and you can see below some black and white bars which I'm currently looking at, and it will soon start detecting that I'm looking at the targets, and it will make them more difficult. So again, as I'm looking around the screen, I'm just following these. You see now it's made it more difficult because it realizes that I'm actually looking at it. And again, and it will soon detect that there and make it even more difficult. You may not be able to see this, but there are still a section of bars there at the moment. I must have missed that. So again, it's made it a little bit easier for me. And again, it will, there we go, make it more difficult again now. And if I keep successfully looking at the bars, then eventually it will end the assessment because I'll have achieved a good visual acuity measurement. Unfortunately, in this case, I'm not doing that because, again, my head's moving a little bit too much here, and so it's detecting that I'm not looking at the actual gratings at the moment. So as you can see, the grating is getting easier and easier because, but it's also measured a good level of acuity for me, so it actually will probably pass me on this assessment. Again, it doesn't really matter if you don't look at once you've reached a good level of visual acuity, because it will simply record the best acuity that it detected during the assessment. And as you can see there, it's more or less given up now. So it should terminate the test early if it decides that I'm no longer looking at the screen, or I'm not participating. Shortly it will terminate. There we go. So it says I failed the screening, and that's in bold red. Again, in this case, the reason for that was because I was moving my head because I was talking through the assessment. As you can see there, the summary is quite informative. It tells me when the assessment was done, who did it, and who they did it on. It tells me how it was done. It gives information about the webcam. It gives information about the screen, including more technical information such as how many pixels there are in each centimeter. It also explained what the criteria was for passing the test, and it explains that over 100 seconds there was a 70% accuracy rate. I was about 59 centimeters away from the screen, which is about right. And in theory, I could have achieved 0.0 logmar. 0.0 logmar is effectively 20/20 vision. But I didn't get that. I got 0.45 logmar. And again, these units of measurement are very very good clinically. They don't really need to mean a great deal from the point of view. All it really matters from this assessment is whether the assessment was passed or failed, and therefore the recommendation is to get an eye test with a qualified optometrist. That doesn't necessarily mean, of course, their vision is poor. It simply means that the screening assessment was below the threshold which recommended that the patient passed. If the person passes this assessment, then they've got good vision. If they don't pass the assessment, then you need to find out if there's a problem or not. And there may not be, but you need to get a qualified optometrist to find out. So at this point, I'd be ringing up and finding out if anyone could come and see this person to find out what's going on with their eyesight. Once you've done the assessment, you can then, of course, again print it out. You can save it, or you can just restart it and do the assessment again. And certainly if the person fails the assessment that does pretty well, it's quite likely that they actually could pass the assessment. So I would probably in this case want to restart that assessment, do it again, and see if I get the same result, if I get a slightly different result. Again, you don't have to go through all the calibration steps. You can just repeat the assessment, and you can do it in theory as many times as you want to get a good idea. And certainly if you're going to bring in an optometrist to find out what's going on, I would probably suggest repeating the assessment maybe 2-3 times, just to see if you get the same kind of information back or if you get different information. And that's the end of this tutorial. I hope you found it useful, and good luck with your assessments.